All right, so last week we spent a lot of time talking about how to graph quadratic equations, and today we're going to start talking about what it means to solve a quadratic equation, and we'll talk through several methods to do this, but the one we're going to focus on today is to solve by graphing. So it's kind of similar to when we were solving systems, and we had a few methods to solve. We had graphing, substitution, elimination that we worked through. Today we'll focus on solving quadratic equations by graphing, and then we'll move on to some more algebraic methods on other notes. So here, first thing we want to talk about, it says, remember standard form of a quadratic function is y equals ax squared plus bx plus c. So standard form is where we write it with our largest exponent in front, that x squared, and then we work our way to x to the first, and then a constant with no x. Today we're going to solve quadratic equations by setting y equal to 0. So it's the same form on the right-hand side, but we'll set it equal to 0. And essentially what we're doing here is we're trying to figure out what can I plug in for x that makes this 0. So solving a quadratic equation means to find the values of x when y is 0. When you plug the x values in, you should get 0 out. So that's what it means by solving. What are the numbers? And there should be, for most problems, 2 solutions that make the x value 0. So there are cases where you'll only have 1 or sometimes none, which we will cover as well, but most of the time you're going to get 2 x values that make your equation 0. So first thing we want to do is graph the quadratic so that we can see what's going on here. So remember, we do opposite of b over 2a to find our x coordinate of our vertex. In this case, my b is 0. So I'm going to have 0 over 2 times 2, which is 0. So my middle point here, my vertex, is going to be 0. So then I'll do 1, 2, and -1, -2 for my other points. And then let's go ahead and plug in our 0. So 2 times 0 squared minus 2 should give me a -2 out. If I plug in 1, 2 times 1 squared is 2. 2 minus 2 is 0. And then if I plug in 2, 2 times 2 squared should give me 8 minus 2 is 6. And I plugged those in kind of fast. But you should be able to just type them in your calculator if you want as well. So then I'm going to graph my quadratic here. So it should look something like this. But what we're looking for is where does it cross our x-axis? Or in our table, where is the y 0? And in our case, it is 0 at -1 and +1. So we will say x equals -1 and +1. And this is our answer. These are the x values that would solve our quadratic equation that would make it equal to 0. Okay? So let's try another. Same kind of a thing. To find my x coordinate, I need to do -b over 2a. So in this case, that'd be +4 over 2 times -1, which is -2. So my middle vertex point is going to be -2. So I'll do -1 and 0, -3 and -4 for my other x coordinates. But let's start by plugging in -2. So here I'll have the opposite of -2 squared minus 4 times -2 minus 4. So this would give me -4 plus 8 minus 4. Looks like that's going to give us 0 right there. And then if I plug in a -1, that would give me -1 plus 4 minus 4 is going to be a -1. And if I plug in 0, I should get -4. So I'm going to go ahead and draw our picture. -2, 0 would be over here actually. And then we have these 2 points. So our parabola should look something like this. And now this is going to be one of the times where we just have one solution because it's only touching our x-axis once. So again, most of the time we'll have 2. There are cases like this where you end up with just 1. And -2 is where that x is 0. It's also touching at -2. So we have x equals -2 for our final answer there. So a lot of times you can find them even just in your table without drawing the picture. I think it's good practice for now to do both since we're still new at this, but you're just looking for where's the y 0. There are 3 possibilities. So I've already mentioned this a couple times. 2 solutions is going to happen when your vertex is above the x-axis but faces downward like this, or if your vertex is below the x-axis and faces upward, because then it's going to touch twice. One solution is going to be when your vertex is on the x-axis, so it could be either of these where it's just touching the one time. And then you could also get no solutions. No solutions are going to happen when your vertex is above and opening upward, because it's never going to cross down here like we need it to. Or if your vertex is below but facing downward, because again, it's never going to cross our x-axis. So that's what it would look like visually to have 2, 1, or no solutions. All right, last problem for today. We're going to do a little word problem here. It says a dolphin, misspelled dolphin there, a dolphin jumps out of the water. The quadratic function y equals -16x squared plus 20x models the dolphin's height above the water after x seconds. How long is the dolphin out of the water? So we know and it's already labeled on our picture here, at 0 seconds, our dolphin is at 0 feet. If that's what they're using to measure. That's where it's starting. So then it's going to come to a peak here at its vertex, and then we'll have to figure out what the end point would be. So let's try to find the vertex, where we do opposite of b over 2a. So -20 over -32 should simplify. Let's go ahead and do a decimal to be 0.625. So at 0.625 seconds, then we can figure out how tall that is if we want. We can plug it in. Which is 6.25 feet. And then to get back to 0, since these are symmetrical, I did 0.625. I can do that again. So essentially we double that, and it's 1.25. So how long is the dolphin out of the water? 1.25 seconds. All right, that is it for your notes today. You can move on to your assignment.